Okay, so here's another example of an unbalanced chemical reaction where you're asked to find the limiting reactant. So if you want, read with me here. So it says that we have 15 grams of each of the following aluminum and hydrochloric acid, and it reacts to give us aluminum chloride and hydrogen gas. Okay, and this particular problem specifically states that the function is unbalanced, and even if the problem that you're given doesn't state that it's unbalanced, a good rule of thumb is to always check to make sure it's balanced. So here I'll balance it for you. So if you don't know how to balance equations well, I say pause the video and learn how to balance things first. Otherwise, the rest of the work would be a waste of time because the rest of the work is dictated by the coefficients in front of a proper, correct balance equation. All right. So if you know how to balance things properly, quickly, the coefficients in front of each of these reactants and product side will be 2, 6, 2, and 3. Again, pause the video if you don't know how to get those things and work on that. Otherwise, you'll be wasting the rest of your time doing this stuff. Okay, so we're asked to figure out which is the limiting reactant. So right away, I'll just focus on the left side of the equation because your two reactants for this problem is aluminum and hydrochloric acid. So I don't really have to worry about the product side. So I just white that out for you to kind of see and focus on just the left side. Okay. So the mole ratio here is for every 2 moles of aluminum, you need 6 moles of hydrochloric acid. All right, so let's go ahead and get going. For this one, you can go from mass to moles, okay? And it doesn't really matter what you start with for this one. I have just chosen to start with 15 grams of aluminum, which is the first reactant that I have on the screen. Again, it doesn't really matter if you start with hydrochloric acid or aluminum. The process remains the same. So here I started with 15 grams of aluminum, which is stated in the problem. It says you were given 15 grams of each reactant. So you have 15 grams of aluminum, and again, you have 15 grams of hydrochloric acid. So we need to convert grams of aluminum to moles of aluminum simply by going through the molar mass step. So for every 1 moles of aluminum, there's 26.98 grams of aluminum according to the periodic table. So if you do your calculator work, you'll get a value of 0.556 moles of aluminum. Okay. So again, if you set up your stoichiometry conversion stuff correctly, grams of aluminum cancels out as you saw on the screen that just came up. And then we're left with that. Now, if we know moles of aluminum, we can go from moles of aluminum to moles of hydrochloric acid simply by looking at the mole to mole ratio. And this is where the balance equation is going to be crucial to your work. Because if your equation is not balanced properly, your coefficients will be wrong. And if your coefficients are wrong, your calculator work will be wrong. Okay, so here's mole to mole. Now that in the first step, I have 0.55 moles of aluminum. I can convert 0.55 moles of aluminum to moles of hydrochloric acid just by doing mole to mole ratio. So I started with the answer in the previous step, which is 0.556 moles of aluminum. I put that over my usual sexy 1. And then I put the ratio of moles of hydrochloric acid to moles of aluminum based on the balanced equation there. So the 2 comes from there, and then the 6 comes from right in front of hydrochloric acid. So the ratio is a 2 to 3 based on the balanced reaction. And then if you do calculator work, really simplifies down to 6 divided by 2 is just 3. So if you want, you can punch in 0.556 times 3, and it yields about 1.67 moles of hydrochloric acid. But from here, you need to figure out whether Al or hydrochloric acid is the limiting reactant. So we have to do one more step, okay? And that is we have to go from moles to gram because the problem gives us grams of each reactant. So you have to convert now moles of hydrochloric acid to to grams of hydrochloric acid. So here we go from moles to mass. Again, mass in this case being units in grams. So we take the previous answer that we found, 1.67 moles of hydrochloric acid, put that over a sexy 1. And here we need to use the molar mass of hydrochloric acid. So if you use the periodic table, there's 1 H, there's 1 Cl. Add those values up in the periodic table, and the molar mass of hydrochloride should come out about 36.5. And moles of hydrochloric acid will cancel out. This will leave us with grams of hydrochloric acid. Okay. Now, once you get this answer, though, of 61.0 grams hydrochloric acid, you have to know what to do with it. Okay. So essentially, it says you start with 15 grams of aluminum, but 15 grams of aluminum is equivalent to 0.556 moles of aluminum. But if you have 0.556 moles of aluminum, you need 1.67 moles of hydrochloric acid. But 1.6 moles of hydrochloric acid is equivalent to 61.0 grams of hydrochloric acid. So 61.0 grams of hydrochloric acid here is what you need based on your starting point. But if you read the problem, it says you're given 15 grams of each reactant. You need 65 grams of hydrochloric acid to completely react with 15 grams of aluminum, but you don't have 61 grams of hydrochloric acid. You're only given 15 grams. So right away, what you need is way more than what you're given, which would imply that you're short. Okay, again, you need 61, but you're only given 15 grams. So right away, I don't have to do any further work. I know that this is my limiting reactant, which is hydrochloric acid. All right, so let's move on to the second strategy, which I like because it's a little quicker for me. So hopefully you like it. Again, start with the balanced reaction here. Everything's balanced. I carry that over from the previous slide. And then I focus my attention here on the coefficients between 2 and 6. From the balanced reaction, we know for every 2 moles of aluminum, you need 6 moles of hydrochloric acid, which can really be reduced down to 1 to 3. Again, 2 divided by 2 is 1. 6 divided by 2 is 3. Okay, so keep that in mind. So from here, I can convert grams of aluminum to moles of aluminum. So in this step, I just took the 15 grams that's given in the statement. I convert that by going through molar mass. So I convert 15 grams of aluminum, which is equivalent to 0.556 moles of aluminum. And in the next step, I'll also convert what's given to me, which is 15 grams of hydrochloric acid. But 15 grams of hydrochloric acid going through its molar mass here is equivalent to 0.411 moles of hydrochloric acid. Okay, so these two steps are pretty easy. The hard part is, again, knowing what to do with these two answers that you just got. You got moles of Al and you got moles of hydrochloric acid. But I think this one is not too bad. So here's the coefficients from the balanced reaction. For every 2 moles of aluminum, which is up here, you need 6 moles of hydrochloric acid. So I just carry that ratio down from the balanced reaction. But basic math tells you, again, if hopefully your multipliers are good, 2 and 6 can be reduced down to 1 and 3 by dividing both sides by 2. So 2 divided by 2 is 1, as I mentioned earlier. 6 divided by 3, 6 divided by 2 is 3. So really it's a 1 to 3 ratio. But here's the difficult part for some kids who don't really know how to do the strategy, which I like. You're given 0.556 moles of aluminum, which I carry down here. This is your given value. The question is, if you're given 0.556 moles of aluminum, how many moles of hydrochloric do you need? But it's easy. It's a 1 to 3 ratio. So whatever this number here is on the left side, in this case 0.556 moles, well, this is just 3 times that. So to me, I'll take this 0.556 moles of aluminum and I'll just multiply by 3. Why? Because it's a 1 to 3 ratio. Okay, so taking 0.556 moles of aluminum and you multiply it by 3, because it said so, you'll get a value of 1.67. Well, you need 1.67 moles of hydrochloric acid. Okay, so again, the hard part for kids is just determining or interpreting what is that you just solve for. So I just figure out how many moles of hydrochloric acid I need, but I don't have that much. The problem gives me 15 grams of hydrochloric acid, which I already converted to moles of hydrochloric acid. So by looking at what I calculated, this is how much I have. Okay, I only have 0.411 moles of hydrochloric acid, but I need 1.67 moles of hydrochloric acid. So right away, I'm given not enough. Okay, because I'm not given enough of hydrochloric acid right away, I know that is my limiting reactant. So the reactant that you're short on is your limiting, hence the phrase limiting. All right, other than that, I hope that helps. Stay nerdy, don't be whack.